3, 2, 1.
Good day everyone. Today we will be presenting our disaster relief database case study, which demonstrates how a relational database can support effective disaster response operations. Disaster response requires rapid coordination of human resources, material supplies, and accurate information. Without a proper system, relief efforts can become delayed, inefficient, and disorganized. In our case study, the Unity Response Center, or URC, is a non-governmental organization that provides humanitarian assistance across Malaysia. Due to the complexity of managing volunteers, relief centers, aid distribution, and disaster events, URC uses a relational database system. This database integrates key entities such as organization, relief centers, volunteers, assignment, aid distribution, disaster events, and victims into a single structured system. So, our major scenario focused on the major Kuala Lumpur flood in September 2025, showing how the database improves efficiency, accountability, and timely aid delivery. Next, my teammate will explain the database structures and key design.
I will now explain the database structure and key design used in this system. Each table in our database represents a real-world entity involved in disaster management. For example, the volunteer table stores volunteer information, while the relief center and disaster event table store operational data. To ensure data accuracy, each table has a primary key that uniquely identifies each record. Examples include volunteer ID, center ID, and event ID. Foreign keys are used to create relationships between tables. For instance, volunteer ID in the assignment table links volunteer to their assigned relief center. We also use alternate keys such as IC number or email address. These fields are unique and act as identifiers even though they are not selected as primary keys. This key design prevents duplicate data, maintains referential integrity, and ensures accountability, which is critical during disaster response. Next, we will demonstrate how this database works through SQL scripts.
I will now demonstrate several SQL queries that show how our database supports analysis and decision making. The first query identifies the relief center that handled the highest number of aid distributions, along with the volunteers most frequently assigned to that center. This query uses a common table expression to calculate the total number of aid distributions per relief center. A subquery with the max function is then used to find the busiest center. By joining this result with the assignment and volunteer table, we can identify the most active volunteers at that center. This information helps management to identify high-demand locations and allocate resources more effectively. The next query calculates the total assignment duration for each volunteer. We use a left join to include volunteers with no assignments and coalesce to replace null values with 0. This allows administrators to recognize highly committed volunteers and plan future deployments.
I will now demonstrate on additional SQL queries focused on operational decision making. This query identifies volunteers with medical skills whose assignments started before today. This is useful during medical emergencies when qualified volunteers are urgently required. Next, this query calculates the total 8 items distributed per disaster event by category. This helps planners understand which 8 items are most needed for specific disasters. We also analyze the number of victims by age group for a disaster event using conditional aggregation. This allows targeted assistance for vulnerable groups such as children and seniors.
I will now present the final set of SQL queries and conclude our presentation. First, this query identifies the organizations that manage the highest number of relief centers. By counting the number of relief centers linked to each organization, this query helps us evaluate organizational capacity, responsibility, and operational skill in disaster management. Next, we retrieve vulnerable victims, especially children and senior citizens who are registered under a specific disaster event. These age groups are more vulnerable during disaster and typically require priority assistance, medical support, and targeted aid distribution. This query supports better resource planning and victim prioritization. Finally, this query identifies 8 items that were distributed in quantities higher than the overall average. In this query, we first calculate the total quantity distributed for each 8 items. Then, using a nested subquery, we compute the average distribution quantity across all items. Only 8 items with total above this average are selected. This allows disaster response team to identify high demand resources, ensuring future supply planning is more accurate and efficient. Overall, all our SQL queries demonstrated are fully functional and executed successfully. Our database design supports complex analysis through joins, subqueries, aggregation, and conditional logic. The system improves efficiency, accountability, and decision-making in disaster relief operations. Thank you for your attention.